You set up your composite, hit play, and spot the error. The replacement video floats, slides off the edges, and disconnects from the television frame. The instinct is to rely on traditional point tracking, but point trackers look for isolated, high-contrast pixels. If the camera pans quickly, motion blur smears those corners, leaving the software with nothing to hold onto. This diagram illustrates the alternative, planar tracking. Instead of hunting for independent pixels, the engine analyzes the object as a flat 3D geometric plane. It calculates how that entire surface translates, scales, and rotates as a single mathematical equation. To achieve a flawless track, you have to abandon your first instinct. You cannot track the glass screen itself. When you feed the tracker information about the physical plane, rather than the glowing pixels, screen replacement becomes a predictable, stable science. Methodical. Step 1 is to open the Mocha AE interface and locate a frame where the television is clearly visible during the panning shot. Grab the X-spline tool from the top menu. Think of this tool as your magnifying glass. It draws the exact boundary that tells Mocha where to search for movement data. A common mistake is to draw this boundary directly inside the shiny, highly reflective area of the screen. This cross-section shows why that fails. Reflections on the glass move independently of the physical television. The solution is to draw your X-spline wide, capturing the matte bezel and surrounding flat wall. These surfaces share the exact same movement physics. They are coplanar. Even with a wide boundary, we have a problem. That large X-spline shape still encompasses the reflective glass right in the center of the television. To fix this, select the Add X-spline tool. Draw a second shape entirely inside the inner boundaries of the television bezel. Look at this tracking area. Placing a second spline inside the first creates a definitive blind spot. This specific shape forces the software to ignore the moving reflections, locking its focus entirely on the stable outer frame. Now initiate the forward track. The software will calculate the 3D movement of this hollowed-out shape frame by frame. Using subtractive logic allows you to track any highly reflective object. You succeed by explicitly telling the computer what not to look at. Instructive. With the track complete, we move from the search phase to the placement phase. The red X-spline shape we just drew does not dictate where your new video will go. Notice the distinction here. We need the planar surface tool, the blue box. Think of it as the precise sticker for your final projected video. The X-spline searches the room to gather the movement data. The planar surface takes that exact movement and applies it to a specific geometric area. Turn on the planar surface and drag its 4 blue corners directly onto the physical inner corners of the TV screen. Zoom in closely on each corner. You want pixel-perfect alignment against the bezel to ensure the new video fills the frame precisely. Decoupling the data search area from the video placement area is the functional foundation of advanced planar tracking. Before committing to an export back to After Effects, you need to know if the track is actually stable. To test this, activate the Show Grid function. Enabling the grid projects a high-contrast colored mesh directly onto the coordinates defined by your blue planar surface. Scrub aggressively through the timeline. You are hunting for any sliding, drifting, or shaking in how the grid aligns with a physical television. A successful track has zero give. The grid should look like it is physically painted onto the glass of the television. Verifying with the grid proves the math is solid, eliminating all guesswork before you build your final composite. With the track verified, export the tracking data out of the Mocha interface and return to your After Effects timeline. Apply this imported corner pin data directly to your new replacement video layer. Watch the final composite. The new video replaces the screen flawlessly, holding the exact perspective of the room with zero drift. The process is strict but repeatable. Search the outer bezel, subtract the internal reflection, place the target surface, and verify with the grid. This exact workflow scales up. You can use these exact steps to track highway billboards, handheld phone screens, or complex architectural surfaces. True VFX integration happens when you stop looking at pixels and start analyzing the physical geometry of the scene. When you understand the structure, you know exactly what to feed the tracking engine.